Okay, I think we can start. Well, first of all,
Great.
welcome everyone to a Nook Tech Dive series. We are very excited to have you here today. We're gonna be taking you into a deep dive into Barbara's Edge AI platform and demonstrate how to deploy models and applications at the edge through different use cases. I'm Emilia de Zoom. I'm an SDR here at Barbara. And as I said before, we're very excited to have such a great group today, and we're very thankful for you being here. Before we start, just let me say that we would like to encourage you to make any questions and to make the session as interactive as possible. So please feel free to use the Q&A feature to raise any questions during the whole session. We'll be addressing it with Enrique as we go. So with no further ado, I would like to introduce our solution architect, Enrique Ramirez. Together, we're going to be walking you through the main aspects of the platform and the key features. Just before I let Kike take over, we'll be sharing some relevant contact and resources related to today's topic, so make sure to keep an eye on the chat. So Kike, I'm going to let you take over, and thank you once again. Oh, I think I
I was
I was
mute.
just gonna say that.
I was mute. Thank you, Emilia. Thank you for the introduction and hello, everyone. Yes, this is the October session of our Tech Dive. Okay. As always, in the Tech Dive, we are going to have a brief overview of the platform. What can we do using Barbara? I'm presenting some use cases. Okay. So I think it will gonna be a good introduction to those who doesn't know the platform and who want to understand the possibilities of what can they do with it. Okay, so let me share my screen. I will try to uh, share with you a presentation we have prepared for today. Okay, and well, this way. Uh, Are you seeing the presentation? I think so, isn't it? Yes.
Yes.
Okay,
Yes, yes.
fantastic. So let me share the agenda we're having today. And it is a really basic agenda. We are going to focus on the most important things, okay, which are basically an introduction to know why to use Edge AI, okay, what are the benefits of using the Edge instead of the cloud when performing computation, okay, especially in the industrial world and especially when using AI models. Then we will present a couple of case studies, okay? The first one is calculation of the parameter called OEE. This is an overall equipment effectiveness. This is a way of calculating how good is performing any any system in the industrial world, any machinery. Okay, so we are going to simulate a CNC machine today and try to calculate this parameter for that equipment. Okay, and then we are going to overview a complete UNS implementation. Okay, also using Barbara, we will see how to deploy all the application needed to have a complete UNS system, to get all the information in a company and having this single source of truth that we always use in UNS. Okay, and then when we have seen these two cases, okay, and we have seen how to deploy these two cases, we will go deeper in the platform. Okay, we will see how we can go beyond the possibilities using Barbara. We will see how to provision in new machine. We will see how to deploy application and AI model, the way to manage devices. We will finish with this main functionality we have. The first one is batch command, so the way to manage big group of devices all at once and in parallel. And then we will see an example of using high availability, which is one of our latest feature, which is also quite demanded. Okay, so that is what we are going to do today. Okay, so again, thank you for being here. And let's start. Let's go see directly the reason to use Edge AI. Okay, at the end, when we speak about Edge AI, is basically a new technology to remotely deploy, run, and manage data analysis application and AI model on distributed on-premise devices, as opposed to do it in the cloud. Okay, and the key here is distributed on-premise devices. Okay, we are speaking about devices which are normally industrial PCs or machines that distributed a lot of different equipment distributed all over the world. So in that cases, when you have to manage these devices, when you have to deploy some application or some AI model in 100, 200 or 1000 different equipment that are distributed all over the world, it is the only option you have to do it in an optimal way is using a platform like Barbara, which allows you to manage all of them at once. Okay, that is the the reason why Barbara exists. Okay, we can do this using Barbara. We can handle different machine and the application and AI models that are running on top of that machine. Okay, so uh, why should we change the computational task from the cloud to the edge? Okay, why should we do that? There are several reasons. Okay, we have some key factors here. Okay, for example, when we are speaking about cost, the costs at the cloud are normally non-predictable. Okay, so you have to pay depending on the computer resources you are using, right? So in case your data increases or your use case get bigger, your cost in the cloud will also get bigger. Okay, and this is something that normally don't used to happen in the edge. Okay, at the end in the edge, you use your own equipment, you use your own hardware, and the costs are fixed. Okay, so this is one of the reason we have for moving from the cloud to the edge. The second one, obviously, is very important. Also, this is one of the main case that make our users move from one side to the other is the security. Okay, here is a good data, a good point mentioned. 61% of the cloud services receive attacks during 2024. Okay, so the public surface of the cloud make it really vulnerable to attacks, and that is something that you can avoid when you are using the edge. Normally, the edge machines, the edge nodes, are located behind corporate firewall, so they are more protected. It is quite more difficult to attack some machine that is in the edge than one that is in the cloud. Okay, so this is another key. The third key, privacy, is really, really, relational with the security, because at the end, if you want to have privacy, the best way to have it is don't send your data to the cloud. Okay, when you keep your data on premises, when you own your own data and this data doesn't leave your premises, it is the best way to keep privacy. Okay. Finally, we have also a key factor that we call a friendly, okay? Because normally the solution that you will find in the cloud to deploy application, this kind of thing, they have IT software interface, okay, and it is really hard to understand, really hard to learn to use, especially for OT people. Okay, remember we are focused on the industrial world. When some of the people that normally work in the OT side try to use one of these solutions, it's really hard for them. And in the edge, we have, especially Barbara, we focus a lot on that. We have a user interface that has been designed thinking about our user, okay, and we always try to make it as easy as possible to use. And normally OT people recognize that and they are happy with that, okay? So they are key factor to move from one to the other. There is one more I always want to like to mention, that is latency, okay? Because normally when you are sending your data to the cloud to be processed there and then you receive the result, the time from the moment you send the data to the moment you receive the result, this latency is quite higher than when you are doing all the processing and all the calculation locally near the data. Okay, that it is the edge especially. So it is another factor that normally make our user to move their computing power to the edge instead of having it in the cloud. Apart from that, I would like also to speak a little bit about our AI ecosystem, okay? Because at the end, we are a platform, okay? And our customer, they don't really need a platform, they need solutions, okay? So Barbara is a platform that helps you to get this solution, we help you to get that, and we have some partners and some other resources surrounding platform, the platform, the Barbara platform that make it possible. Okay, so let's say we have the Barbara Edge AI ecosystem that is basically composed by some partners that develop AI models. Okay, in case our customer needs an AI model, we don't develop AI model, but we have partners that do that. Okay, and we can help them to deploy this AI model to the customer. We have also data acquisition tool and solution and partners that make it possible to get the information from any system, from any sensor, from any SCADA for everywhere. Okay, we have also some complementary platform. You will see them later in the marketplace, so we can integrate with third-party tools, really common in the industrial world. Okay, and finally, we have also partners that provide edge hardware. You will see that we're a software platform, okay, but we need the hardware to run the Barbara Edge node. We don't provide the hardware, but we have partners, really good partner and well-known partner that can help you to get the hardware available. Then one, we have to build an architecture using the edge technology to solve any use case from our customer. We also have some well-known system integrators that are also partner of us that will make it possible for you using the Barbara platform. And you will find everyone in the link that Emilia has sent to you to find all the partners we have in the Barbara ecosystem. Okay, so let's focus on this diagram because I would like to start speaking about Barbara itself, okay, and how do we work. And this diagram make it very easy to understand, okay? So at the end, we are an orchestration platform that make it possible to deploy any edge solution. Okay, we are a really horizontal platform. We can work in any vertical for the industry, and also we can cover a lot of different use cases, not only data collection, but also, I don't know, streaming analytic or UNS, as we will see, computer vision, cybersecurity, anything. Okay, we can do anything. How is that possible? That is possible because we are a platform that is focused on managing application and not data. Okay, we are not a data-oriented solution. Normally, solutions that are data-oriented make one thing, but they do one thing really well, but only one thing. Okay, we are in a higher level. We don't manage the data directly. We manage the application that usually manage the data. Okay, so being at that level makes us possible to be such an horizontal platform. Okay, here you have the diagram on how we work. Here, what you see, this blue box we have here is what we call a Barbara Edge node. Okay, what is a Barbara Edge node? This is very simple. A Barbara Edge node is an industrial PC machine or a virtual machine, okay, that is normally deployed in the edge. And what is the edge? The edge is on premises, okay, on a customer premises, normally really near where the data is produced, okay, in a factory plant, in a vehicle, in a, well, I don't know, it can be located anywhere, but on premises, okay? So what should we do with this machine to convert it in the Barbara Edge node? The first thing, this machine needs to have installed what we call the Barbara core. We have it here. The Barbara core is our operating system, right? And it is an operating system developed by us and based on Linux, and it is designed thinking about cybersecurity. Okay, so it is an operating system that from the very first minute when you install it in a machine, the machine gets total protection. Okay, so all the communication are outgoing and secure. There will be no open ports. There will be no SSH access. There will be no administrator user. A lot of different cybersecurity measurement that we will see in some seconds, okay, in a couple of slides apart from this one, and make the device ready to be certified in the AIC 62443 specification for cybersecurity in industrial environment. Okay, so the machine is protected, what you have this OS. And also it connects directly to our API. And above the API, we have Barbara panel, which is the interface we are going to use to manage everything, okay, using Barbara, and also the marketplace. And the marketplace, it is just an application hub, okay, that contains over 150 different applications ready to be deployed in the Edge node. Okay, so here you can see that we will use panel to manage the devices and also to select application from the marketplace and installing them here. Okay, and check this plane because I like to remark it. With this plane divide the orchestration plane from the solution plane. Okay, so you install application here, this side, to create different solutions, okay? And this way, here you will see the solution. In this part, you will see the data moving from the sensor to the edge device is being processed here, sent to any third party in the cloud or whatever, okay? But that also means that there will be no user data in panel. You will see it later, okay? We don't have your data in panel. We only have the information about the application, about the log, about the configuration, okay? But if you want to see the data, you need to access to this application here. That is why we live in the orchestration plane, not on the solution plane, okay? That is very, very important. And finally, the platform itself, composed by the API, by panel, and by marketplace, can be deployed either on cloud, okay, that is the solution we are going to use today, but it also can live on-prem, okay, depending on the use case. Some of our class customers prefer to have the solution, one instance of the solution installed in their own, servers, so we can do that. But if not, you always can use the SaaS service, okay? So and this is another way of seeing the solution. We can see we have different levels. We have the field level, okay? The edge level, where you have here one edge node, okay? This edge node has Barbara Core installed. It connects to panel and marketplace, which are on the cloud or on-prem, and then you can use this platform to control the edge node and to send application, AI model, or whatever to the edge node, okay? So this way you can access to this application using a remote access, okay, and also a local access. If you are in the same local network than the edge node, you can access it locally, but also you have this remote access to the solution. And you can also access panel directly, as we will see in sunset, okay? So this is the overview of the platform, okay? So now I would like to start showing you how to deploy a couple of basic use cases, okay? Well, not so basic. At the end, they are quite interesting. The first one we are going to see, well, let's start showing this slide that, well, at the end, it summarizes everything. We can use the Barbara platform plus different edge nodes to deploy in different solutions, okay? We have list here 5 different solutions that are really, really common for us, okay? That are some of the big group that our customer demand us to do with the panel, which are data ops and unifying namespaces, predictive analytics, computer vision, software-defined automation, and cybersecurity. But we can deploy anything at the end, okay? So that is some example. Today, we are going to focus on, I would say, a solution that is, let's say here in predictive analytics, which is the calculus of AAI, and also the UNS, the Unified Namespace Solution. So let's start with the OEE calculation. What is the OEE? The OEE is the overall equipment effectiveness, okay? And what we will do is, let me show you this way. This is the architecture we are going to deploy in an edge node, okay? What we have here, we have an edge node, this box is an edge node. We are going to deploy an MQTT broker, okay? We always like to use this kind of architecture using a central broker because it decouples perfectly the data origin from the data consumer, okay? And it makes it very resilient scalable, so it is very powerful. So we will have a broker. Basically, in the broker, we will have an application that is called Industrial Data Simulator. What is that? It is an application that simulates any machine, okay? It is very helpful for us, and today we are going to use it. We are going to simulate a CNC machine that is basically publishing in the MQTT broker some data of the performance of the machine, the number of pieces that it's making, the energy consumption, etc. We will see in action in some seconds. Okay, so it is publishing everything here. And then we will also install a Node-RED. Okay, using Node-RED, we will connect to the broker. We will get some information from this CNC simulated machine, and we will calculate the OEE parameter. Okay, and now we will see how we will do that. But basically, once we have this calculation done, we will publish back it here to the broker. Okay, so we get the data, calculate a new parameter, and publish everything again in the broker, right? Then we will have an InfluxDB database, okay, with an ingestor that will make it possible to get all the information from here and storing locally in the InfluxDB. And then we will have a Grafana, which is an application really common to a dashboard. Okay, so we will have a dashboard to visualize all the information together. Okay, so that is what we are going to do. Check. We call this architecture Ming, and it's a normal way of calling this kind of architecture because you use MQTT, InfluxDB, Node-RED, and Grafana, which are the acronym for MING, and that is why we call it Ming. Okay, so we can deploy different use cases using this one, and this is just an example. How we calculate the OEE parameter? The OEE parameter is only the result of multiplying the availability of the machine, that it means how many time is available the machine. Okay, if the machine stops, it is not available. It is running, it is available. So just calculating how many time has been available versus the overall time. Okay, that is the availability. The performance is how well is performing, how, let's say, how optimal, if it is performing in an optimal way or not. Okay, at the end, in that machine, in that CNC machine, we have a cycle time, okay, time for building a piece. Okay, in case it take more time, the performance will be lower, and if it get the best time, it will better. Okay, and finally, we have the quality. We have some data regarding the quality of the pieces that the machine is building, so we can compare okay pieces versus total pieces, and this way we will calculate the quality. Multiplying the three, we will see the final factor, the OEE factor, which is a very good way of checking if we can do something to improve the efficiency of any machine in any line in any factory. Okay, so let's start. I will just move to the Barbara panel, and we will deploy this use case very quickly, right? So this is panel, we will see it later, okay, in more detail, but at the end, what I have here are edge nodes, okay? Every node here is a different machine. I can see where are they located, okay? And I can start working with them. So let's select this equipment I have here, okay, to deploy this use case, right? So what I am using here is basically an Advantech APC 3301, one of the compatible devices we can use here. We will speak about it later, okay? And I can see the telemetry with the resource consumption of that machine. I can see the network parameters, okay? I can see I have a VPN here that can be enabled to access this equipment, okay? So let's focus directly on this part, the applications and model part, where I can start sending application, okay? And for this use case, I am going to use several applications, but all of them are available in our marketplace. We will speak later about the marketplace, but as you can see, we will use, for example, I don't know, an MQTT broker. Okay, so we have an MQTT broker available here. Okay, this one, and we are going to deploy this one. For example, we have here also the industrial data simulator. Okay, let me show. This is the application we are going to use for the industrial data simulator. So everything comes from the marketplace. Okay, I just need to add it to my library, but as you will see, we have already included to save time. So let's start deploying the pieces we need to use. Okay, the first piece is the broker. I will start deploying the broker because it is the main application we will use for the communication backbone. So I just select, I want to add a new application, which is the broker. I select the version, okay, the latest one. Then I have a wizard to configure some parameters in the MQTT broker, for example, the password, the user, the certificate, if I want to use some security here, if I want to use a bridge mode, the topics, anything, okay? So I will just leave the default value and I will send it to my edge node. So this way, you will see that now we have a new card indicating we have a new application, which is the broker. I can stop and start the service. I can update the version if I have a new version or whatever, okay? So everything is here. And here in the log viewer, I can see the log of this application in real time, right? So we have this broker already deployed in the edge node. So what am I going to do right now? I'm going to use an application called MQTT Explorer. Okay, so let me move it to this screen. Here we are. So this application can connect to this broker remotely. Okay, so this way I can show you how can access to the broker and start checking the information we're going to publish there. Okay, so how can I connect to this broker? It is very simple. I just need to check that the IP of the VPN of this machine, which is already enabled, okay, I can use it to access this machine remotely, is this one. Okay, so I can copy this IP. Okay, and then I can set the host of my MQTT server is this IP I have just copied. The port is the 8883 and the name is this one and the password is this one, okay? How do I know that? Because here in the configuration, I can check that the password is here, okay? The password is this one, the user is this one, and also I can check that the port is also configurable, it's this one, okay? So once I have done that, I can connect to this broker. It is already connected, and you will see that there is no information here. Why not? Because I am not publishing anything in this broker. Let's do that using the industrial data simulator, okay? So I will just add a new application, which is the industrial data simulator. And remember, we are going to use this application to simulate a machine. How can we do that? We will select the application, we will configure it to basically to connect to the broker we have just deployed, okay? And check, we have also the possibility to, well, indicate the volume where we are going to persist the data, and I can send some configuration here, okay? So I will use a predefined config I have prepared here, this predefined configuration. Let me load it and I will show you how it works. Basically, we say I want to get the data from this file, which is a CSV file, okay? I will publish new information every 5 seconds, and I will put this name CNC01 to the information that it publishes in the broker. So this way, if I send this application, right, I will see that I have this industrial data simulator that is running. I want to check the logs, and I will see that normally we have an error because there is no CSV. It is obvious because we have not included the information from the CSV. So what I will do is just stop. Sorry, I will show you how can we upload the CSV to this application. This application have a service called File Browser that is available in this port that allow me to upload any file to the application, okay? So this way, what I'm going to use is this CSV. So in order to enter in the File Browser, I need to check the IP again of my edge node. And using this IP on the port 8088, I will be accessing to, sorry, not 8088, it is 8888. Here we are. So we are accessing to the file browser. I can just set the user and the password. And I can see I have here a folder called CSV file. It is empty, obviously, so I just need to upload a file from my laptop. I have prepared it here. Okay, here we have it. This one is the correct one, so I am uploading it, and here we have the new CSV that basically contains the information I want to publish in the broker. So now, once we have it, we can go back to the industrial data simulator, okay, and we have to stop it and then start it again to make the change available, okay? So once it's stopped, we will run the application again. We can see it has been rebooted, and now in some second we will see that it is finally publishing the information. Okay, it has started and it is publishing the information normally, and we can check that it is sending data, as you can see here. And if we go back to the broker, we can see that now we have some information here, and we are having the information of this TNT01 machine with the energy consumption, with the status, with the order ID, all the data we have here, okay? So we are now simulating this machine. The next step, what is the next step? We will just deploy this Node-RED we have here, okay, to calculate the OEE parameters. So I will connect to the broker using the Node-RED, and I will make the calculation to have the OEE, okay? Let's go and let's do that. So one, I will close the log viewer, I will collapse my card, and I will add now a Node-RED application, okay? A Node-RED is a well-known application that make it possible to process data using blocks, okay? No-code solution, it is very popular. And we can set the name of the application, the version. Again, we have the wizard to make everything easier. And check, we have here a README. This is the link file to the information of the technical note of this application we have in the marketplace. So if you click here, you will see how to configure everything for every application, okay? So following this information, we will set the data volume where we are going to proceed the data on Node-RED. We are going to set the port of the Node-RED application. In this case will be 1880. And here, what I can do is copy and paste a flow, the Node-RED flow already prepared, okay? Because if I leave it empty, when I enter in Node-RED, it will be empty, obviously, and I have to start building the flow. So if I have something already prepared, I can export it using a JSON file and then just pasting it here, okay? In fact, I have prepared a configuration here for Node-RED, as you can see. So here, it is already a flow in Node-RED that make it possible to calculate the OEE, and we don't have to waste time building it. So this way, I will send the application, okay? I will see that we have the Node-RED here. I can check the log. It is creating. It seems to have been started right now. Yeah, here we are, okay? So as you can see here, we have some connection failed to the broker, okay? We have to fix that. Let's do this, okay? Because I will show you why it is happening. In order to enter Node-RED, okay, what can we do? We have to use, again, in the same way, we have to use the IP of the VPN, right? Then I have to put the IP here, put in the port 1880, and this way I will be accessing to Node-RED, okay? It is running in the edge node, right? So we can see the flow here. We will see just in some second. In this tab, okay, we have the flow we are going to use to calculate everything. In fact, we can see here, it is a very simple flow. We are just trying to connect to the MQTT broker, parsing the JSON of every message, and then we have here the code that make it possible to calculate the availability, calculate the performance, calculate the quality, and then the OEE is calculated at the product of the three values one by one, okay? So, and then we create a new payload and we publish it again in the broker. What is the problem here? The problem is that we can see that it cannot connect to the broker because it lacks the user and password here. So I have to put here the user and the password of the broker. And this way, if I update this value and I instantiate again, I will see that it finally connect. Okay. I think it has not connected, so maybe I did something wrong. Just check it again. BBR user. Okay, we're updating, done, instantiate, and here we are. It is, I had something wrong in the password. So we are already connected, and as you can see in the debug, every time we have a new incoming message with the data of the TNC machine, we calculate everything here. Okay, we have this new message sent to the HNO, sorry, to the broker, to the MQTT broker. And we can check it here again, that now we have a second message here, okay? We have this message that has only the calculation of the OEE. So now we have this message with the status of the machine, and this second message with the OEE calculation, okay? So now everything is being published in the broker, as we can see here. What is the next step? The next step is here we have it, is basically deploying the InfluxDB database, okay, and the ingestor. Okay, so this way we will see that how every information here is going to be stored in the InfluxDB database. And finally, we will deploy the Grafana to have the dashboard with all the information together. Okay, so let's do that very quickly. Let's go back to our Edge node, to our application and model part. I will collapse this card. Now I'm going to deploy the database. Again, Influx is a really popular real-time serial database. I will just deploy it using the 4 values. I will not configure anything. So once we have it here, we will see that it is available in the port 8086. Okay, so how can I access the database once it has started? I just need to open a new tab using the same IP of my VPN and the port 8086. So this way, I will enter in the InfluxDB database. I will put the username and password, and I will check that normally if I enter here to explore the data, it is empty. As you can see, we have no data here. It is normal because we have not the ingester. Okay, so let's deploy the ingester, and the ingester make it possible to move the information from MQTT to InfluxDB. Okay, we will configure it to connect to both sides, to both services. Okay, and then in this configuration, I will use also a predefined parameter I have here for the ingester, this one. And what I am saying here is you have to search in the MQTT broker anything that have this device display name, TNC01. We can see that the information we have has this identifier. Okay, so everything that have this identifier will be sent to InfluxDB to this bucket using this name for the measurement in Influx. Okay, so when I send this application and it install, I will see that normally it has started. If now I refresh this view, I will see that now, oh yeah, I have this new measurement here with all this information, so I can make a query and I can see that the information has started to arrive to our database. Okay, so well, we have here all the data um, we want to show in the dashboard. Okay, so let's do this final step. Okay, let's deploy the Grafana. And this way we can add a new Grafana application. Okay, that is a very popular application that make it possible also to create dashboard to visualize things. Okay, so we can deploy the Grafana, we can configure it to access the Influx dashboard, and then it is available in this port. And here it is very similar to what we did in Node-RED, okay? If we don't put anything here, the Grafana application will be empty, so I have to start creating the dashboard. So if I include here a JSON dashboard, a dashboard quoted in JSON format, I will do that. The dashboard will be available whenever you start, okay? So I will include here this information. It is just a dashboard prepared for this, and I will send this application. So now I will see that I have this new Grafana dashboard, okay, and I can access here. How can I access? I will just use the IP of my edge node on the port 13,000, okay. So this way I will access one. I set the credentials. I will access to this dashboard, okay, and we will see we have started receiving the energy consumption, spindle temperature, RMS vibration, and the availability, performance, quality, and the OEE. It takes some time to refresh, but anyway, let me try to do that. It will start very soon to show the parameters here in the same way we have here in this message, okay? So in fact, the problem is that the OEE is zero because there is no availability right now in this moment. The machine is stopped. So that is why we have this no data here, okay? But it is working properly. So this is the way of having this kind of dashboard. As you can see, we have deployed 6 different applications in just one single edge node. And this is the first use case I wanted to show you, okay? This OEE calculation. So, if there is, I don't know if there is any question or something that it is okay.
Yeah, at the moment everything seems to be clear. I don't know if someone would have a question as of right now.
Fantastic. If someone has any question, please write it in the question and answer panel.
Mhm.
And if not, we will continue with the second use case. Okay. And at the end, what we are going to do in the second use case is to show you how to deploy a complete DNS solution, okay? It is a more complex architecture because it's normally involves several edge nodes, okay, not only one like in the previous use case. And at the end, UNS is like a way of having a real-time structure and concept-rich data architecture designed to organize and standardize industrial data for seamless integration across various systems and devices. It is the formal definition. Okay, at the end, what are we doing? We are getting all the information in a company. Okay, having no silos. Okay, it independently of how many factories do you have, how many production lines do you have, how many different machines, different information do you have. We will get all the information, no matter where it is. We will normalize the naming, okay, to have a uniform naming convention, okay. We will use a standardized way to publish the data, okay. And these are the 3 keys in the UNS. All the information, standardizing and using an uniform naming for all of them. This way, if you call T to the temperature in a machine in a location, if you want to read another temperature for other machine in other location, it will be called in the same way and you will have the same structure, okay? At the end, what we have is all the information going northbound, okay, and you know, converging in what we call a single source of truth, a big database where all the information of the company will be available on real time. So this way you can use this data lake or that database or whatever you want to name it to apply AI model, to make processing, to get value from that data and to improve your internal processing. That is UNS at the end, okay? We have here a good way of showing how can we do that. Okay, we have different levels as you can see. We have the feed level on the lower level. We have different sensors with different, machine publishing data. At the end, that's data sources that are located normally on the field level. Okay, in the next level, we have the line level. We are simulating here a food and beverage plant. Okay, so that is why we have this line level and site level. So we are simulating production line. Okay, we have, in fact, we will, in a sample I'm going to show to you, we will have only 2 lines. Okay, but they can be as much as many as you want. Okay, and we have a different edge node. This is an edge node. So there is an edge node per line getting the information from the sensor we have located below. Okay, then we have line 1, line 2, line 3, whatever. Then all the edge node of the line of a single site, of a single factory, will send all the information northbound to this next level, to the site level. We will have another edge node located in every site. And finally, we will have the enterprise level where we will put a single edge node, okay? It can be normally a big server that is getting all the information from all the lower level, okay? And then we normally implement there the single source of truth. So this is an example of the architecture we can use for this kind of situation. We have the field level where we have sensor, PLCs, all the equipment, okay? Then we will have a line level here where we have a single edge node, and this way we will see that we will use an OPC UA connector to get all the information from this machine. We will publish the information in the MQTT broker. We will use an InfluxDB to store the information, okay? And finally, we will have a Grafana I don't know if, are you seeing the slide, maybe?
No, I don't know.
Okay, I need to share it again because I
Okay.
think I have sent you. Okay, here we are.
There we go.
So
Yes.
yes, perfect. Thank you. So I think you are seeing it right now, isn't it?
Yes.
Okay, you're seeing this slide. Fantastic. So as I was mentioning, we will use the OPC UA connector to get the information from this equipment. We will publish it in the broker. We will have an Influx database to store the information locally and a Grafana. And that is really, really similar to what we did before with the OEE calculation. We have not a node-RED here, but we could have a node-RED to make some calculation. But this line level is more or less the same we did before, okay? The only difference we have here is one, we are not using a simulator anymore. We are using a real OPC UA to get information from some machine. And the Sparkplug broker is a special kind of broker that translates the information to the Sparkplug format. Okay. And the Sparkplug format is a standard way to publish the information in the broker. Okay. So using this broker, you can publish the information using the normal way we do, and it automatically translates everything to the Sparkplug format. This way, we will bridge this broker to the next level. So everything that is being published here will be, let's say, broadcasted to this second broker. Then we have the site level here, and then all the information here can be sent to the next level, to the enterprise level. In the enterprise level, we will deploy an Ignition instance. Okay, Ignition is one of our partners. Okay, so we can deploy the Ignition application here, and we will create the single source of truth here. Check that this architecture is absolutely flexible. Okay, we are using this possibility, but what if I have, and this is very common from our customer, okay, I have a factory that is using already an InfluxDB database, but I have other one that is using, I don't know, a Mongo or any SQL database, or instead of Grafana, I have another visualization tool like Plateau or Power BI or whatever. It doesn't matter. Okay, we can deploy anything. So we can change this application, we can change these pieces to adapt to anything that is available, or having one architecture in one line, another architecture in a second line. The only thing we have to check is that the information is standardized when it goes node-bound. Okay. So we have already deployed it in the panel. So I will go to panel and I will show you first the line, okay? Then we will see the site level, and then we will see the enterprise level with the final solution, with the dashboard showing all the information of the factory, okay? So we have in panel, we'll go back to the nodes view, and check we have a group here called UNS solution. Okay, these are 4 different edge machines. Okay, edge node. They have line 1, line 2, site 1, and enterprise. Okay, to simplify things and to make everything easier to understand, we have just two lines, okay, line one and line two, that are sending the information northbound to the site, okay, only one site, okay, and then we will have the enterprise level. So let's start checking, for example, the line one solution, okay. I will use this IP to access the service that are running in this edge node. So I will copy it just right now and check. We have the OPC UA connector, we have the Purple broker, we have the InfluxDB database, we have the Grafana, everything is here. So for example, let's check that in the OPC UA connector, by the way, the OPC UA connector is an application available in our marketplace, okay? It is here, so we can use it to read OPC UA protocol from different machines. So how have we configured it? Check that we have set the name of the URL where the OPC server, OPC UA server is available. We are indicating here the name of the machine, the area where it is located, the line name, the refresh time, with the different variables I am going to read from this machine, okay? Then we have the second machine with this variable and the third machine with variables. So this way, we are implementing the unified way of naming things, okay? Here is where we declare how everything is named, okay? So check that this information is sent to this broker. So let's do the same thing we did before. I am going to disconnect to the previous broker we have in the OEE calculation, and I am going to connect to this one. I just need to change the IP because everything is the same. The port, the username, the password, I haven't changed anything. So I can connect here directly and check that we have some more information. We have the information about line one, and check we have the information about this conveyor belt or this oven or this Dove mixer. Okay, we have different machine here. Also, all of them located in line one. Okay, so I have this topic, Barbara, which is the name of the company, with the location, the site, which is called Barbara 01, and then we have the line one. Okay, but I have the same information here, but using the Sparkplug format. The Sparkplug format check that is non-readable. Okay, it is in binary format. That is why we have this strange character here. The good thing about the Sparkplug format is it is a standard. Okay, for example, it is already standard and compatible with Ignition, and we will use it later. But it has this drawback. It is non-readable. It is not human readable. So we have both information in this broker. The normal information here, human information, and then the translating to the proper format, okay? So we can see here everything, how it is published in the broker, and I can also enter in this Grafana, okay? And I can see that I will open a new tab with the IP of this edge node and the port 13,000, and I will see a dashboard of all the information of every machine in this line one, okay? Here we have it. So we can see all this information for the energy consumption, the temperature of the oven, the humidity of the cooling unit, conveyor speed, Dove mixer vibration level, the Dove mixer motor speed, with the status, with everything, okay? So we have this dashboard containing all the information of every machine located in line one, okay? That is perfect. If we go to the line two equipment, we will see something really similar. But instead of having this Dove mixer or whatever, we have different machine. But at the end, we can see here the configuration of this OPC UA line 2. It has different machine with different variable indicating they are located in line 2. Okay, but the concept is the same, and if we connect to this broker, this one, we will see the same structure we saw before. Okay, so they both send the information to this site level. Okay, here we just have this proper broker here. Okay, and it sent again all the information to the next level, which is the enterprise level. Okay, so this way we will see here we have a couple of things. We have this partner broker that is getting all the information, okay? I will show you that. Let me just open the Explorer again. Okay, here we are. And I am going to copy the IP of this edge node. I will put it here, and now we will see that now we have not only line 1, but also line 2. Both information are available at this level, okay? Everything converges on top, right? And this information that is being published here in the broker is also available in this ignition instance, okay? How can I access to this ignition instance? I just need to check that it is available in the port 8088. So I can open a new tab using the IP 1888, and I will be accessing to this instance. Okay, so what I will do is using the Ignition Vision client launcher, which is connected to this IP, check that this IP is the IP of the edge node. Okay, it is not in the cloud, it is running on the edge node. So we can open this application, and now in some second, it will open a new. Here we have it. Second, it will open a new screen with all the information for this use case, for this UNet use case. Let me share it with you. So, as again, entering the credentials, I will see the final dashboard with all the information moving from the low level, line by line, to the northbound level, okay? So we have the line 1 information in this dashboard with the machine we have available in the line 1, and also the machine we have available in the line 2. In this case, we have some fault codes, some error codes in this machine, so we should check what is happening there to keep my line running perfectly, okay? But at the end, this is the philosophy of this UNS use case. Now having all the information, the ignition, where we can start getting value from that information to optimize everything and to improve the performance of the overall factory, okay? So, well, I think we finished with this solution part, okay? And let's continue. Again, as always, in case you don't have any question, I will continue showing you some low-level details of the platform, okay?
Mm-hmm.
So, I don't know, is there any question, Emilia?
As of right now, no, we don't have any
Okay,
questions.
fantastic. So let's continue. Please don't be shy. And in case you have any question, please indicate it
To
to
let
us,
us know.
okay? Let us know. Yes. Thank you. So let's continue seeing some aspects of the platform. The platform is quite complete. You can do almost anything with the Edge node and with the application. We're going to focus on some detail, but at the same way, in the same, you know, I mean, it is quite easy to use, as you have been seeing. Okay, we put a lot of effort in the user interface, so it is oriented to OT people, people that normally they used to work in the industrial world, and we try to make it as easy and understandable as possible. Let's start speaking about how to provision new devices, okay? Because we have been deploying application to machines that were already there. So what should I do if I want to install a new machine in my factory and register it in Barbara as a platform, okay? Let's start indicating that Barbara is hardware agnostic. That means that we can use almost any hardware, any device for any vendor to create new machines, okay? We have a limited list of compatible devices. Let me show that. We are going to show you where it is in the OS image. But at the end, any Intel machine, Intel-based machine, or any ARM-based machine can be ported or can be used to run a Barbara Edge node. This is the full list of machines we are compatible with. Check, we have different kind of machine, low-level machine like Raspberry Pi for prototyping, this kind of thing, big server, big industrial server for the most well-known vendors. Also equipment with GPU like NVIDIA Jetson, and not only physical devices, we can also run a Barbara Edge node using a virtual machine, as you can see here, right? So the process to register one new equipment is really simple. You just need to select the equipment you want to use. For example, I don't know, this is Schneider Harmony IPC equipment. We download here this OS I mentioned before, this Barbara core, which implements all the cybersecurity features. You download it here, and then you install it in the device. Once you have it, you will have one new edge node here available, and you can start working with it. It is really, really simple, and we call it serial provisioning process. Okay, it is very simple to use. Regarding the OS, this is the full list of cybersecurity, keys or the cybersecurity measurement we have in the OS, okay? So again, no root access, no user password access, all the ports are closed, there is no incoming communication channels, okay? All the channels are outgoing and secure. There is file system isolation, okay? Full data encryption. Every node uses a unique cryptographic certificate, so it makes a good identity management. We use secure boot, we use trusted provisioning, TPM support, and finally, secure and signed OTA updates, okay? So everything together make it compatible with AIT62443 classification. It make our user to save a lot of time when they deploy a new machine. Everything is done out of the box, so you don't have to spend any time securing your equipment, okay? You can be sure from the very first minute, okay? Apart from that, let's speak a little bit about deploy application and models, okay? So what I will show you here is going back to and speak a little bit about what do we have in the marketplace, okay? So this is the marketplace. We have been speaking about it a little bit. We have different categories for different applications here. For example, the industrial category, we have used some application from this category, for example, the OPC UA or the industrial data simulator, okay? We have also connector for Modbus, for BACnet, or IEC 104 for the smart grid sector. We have integration with third-party tools from our partners like Aviva, like Softipack by Schneider, HiveMQ, Ignition Instant, whatever. There is a lot of different applications that allow you to get information from different equipment and move that information through somewhere else, okay? Including, for example, cloud services like Azure or like Google, or even solutions like, Neuron, Litmus, AWS, different possibilities, right? Then we have the storage category, and you will find databases like, for example, InfluxDB that we have already used that, or the ingestor, okay? But we have a lot of different possibilities to work with databases locally at the edge. We have business intelligence tools that allow you to process and analyze and visualize the information locally. We have already Grafana and Lorue, we have been using that, but also more advanced tools like Kafka or Apache NiFi, Splunk, well, a lot of different applications. Okay, then we have, for example, the artificial intelligence category that allows you to deploy AI tools on AI models in the edge node to start working with the AI model. And finally, virtual machine. Okay, we can also deploy virtual machines containing whole operating system like this one you can see in the edge node. Yes, Emilia, I
Yes,
think you have
Chico,
a hand here.
yeah, exactly. We have a question. We want to know what would be the main purpose of using AI tools with Barbara. Do you have any examples of applications running with AI to give feedback or providing recommendations based on generated data?
Yes, we have different possibilities, okay? Because we are seeing we can do different kind of thing using the AI model in Barbara. Okay, for example, computer vision. Okay, we can analyze data coming from cameras and apply AI model to recognize patterns, detect different objects, fire, smoke. There is a lot of different possibilities of analyzing the video and detect different events, object, or whatever, okay? Then we can obviously process data. Everything can be done. So we can deploy AI model that get the information from a broker, for example, analyze the information and publish it again in the broker, okay? And we have also the possibility to deploy tools like, for example, MLflow to work with the AI model locally at the edge, or use application like LLMs, okay, or Llama that allow you to deploy LLMs in the AI model to create chat of this kind of solution. We have tools like Langflow or Flowwise that allow you to create the AI model locally at the edge using this no-code solution. So the possibilities are almost endless, okay? But I wanted to speak a little bit about that because we are not limited to what we have in the marketplace, okay? We can, if you have any application that is not available in the marketplace, or if you have any AI model that is not available in the marketplace, you can also deploy it. And let me show you how easy to do that. Okay, so for example, we have the application library and the model library here. Okay, so if you want to add your own application, you just need to add a new app. And the only requirement we have for application is that they should be based on Docker. Okay, at the end, in the edge node, we are running a Docker engine, so we need the application to be based on Docker containers. You have to deploy here the Docker Compose file, and this way you can upload, you can create your own application, and you can deploy that on your edge node. And in the same way, you can upload here any AI model you have that has been trained by yourself or by any third parties vendors. Okay, so you just need to add a new model, select the framework you have used to train your model, for example, TensorFlow, and then select the engine you want to use to deploy your model in the edge node. Okay, so this way you can create this a new AI model and you can do that, you can deploy that. Okay, so let me show you, for example, using the same node we used it before, okay, for this OEE calculation, okay, I will deploy here in the same edge node a new model, okay, so I have here a ResNet model. It is a basic model to classify images, okay, something very basic. We can select the version the same way we do with application. We can select if we want to use the GPU of the edge node, okay. This edge node has not a GPU, but in case it has, we can select it here. We select the port number where this AI model will be served, and we can send the model. Check that it is so easy. You just need to train your model using, in this case, PyTorch, okay? This AI model has been trained using PyTorch. You save it in PyTorch format, you upload it to Barbara, and all the deployment, all the process to get the PyTorch model, creating the server, using Triton, and sending it to the edge node, everything is done automatically in the background. So it is really, really easy. This way, you will see you have a new card with the name of the model, with the version, with the technology. You can stop and start it, and you will see here at the end, eventually you will see the URL. Okay, I think it is starting and in some second you will see the logs of the server here in the same way we did for application, and in some second you will see here in the URL where you can start sending the request to receive the prediction from the AI model. Okay, it will take some second because it is downloading everything necessary. We can check it later. Okay, so this is the way of working with the AI model. You can do anything you want with them, and it is really easy for, especially for data scientists that normally they are really used to work with model, but not with servers, with Docker, with anything like that. Okay, so you just need to upload the AI model, and everything will be done automatically in the background. Here we have the URL I mentioned before. Okay, we can start sending requests to this URL. Okay, check that this IP is the IP of the VPN of my machine. Okay, and we have also a metric REST URL. Okay, we can see we have another URL that allow me to use another application we have in the marketplace called model monitoring. Okay, and we can use this application to connect to this URL and get all the all the performance, all the metrics of how well is behaving this AI model, and to trigger new trainings or whatever necessary. Okay, so this is the way we work with AI model, and for those which are interested, we will later yeah, we can show you. I have not prepared that, but I think that is a good idea. We have in the academy, in our academy, okay, we have this solution section here where we deploy a complete computer vision solution, okay? That is normally, we did it in the last session in September. We have not done this today, but you have it available in case you want to know how to work with the AI model using computer vision solution. For example, you can see it here. I will just try to publish it in the chat in the same way that Emilia is doing. I think we have it, and you will, here you are. I have published it in the chat. Okay, so let's continue. Let's continue with the. I will share again my screen. Here we are, and I will go back to the slide because we are running out of time. We're just 15 more minutes. I want to, explaining the other thing we can do with the platform apart from deploying application, AI model, everything like that. Let's focus on the how to manage edge node and how to make a batch command, and finally the high availability. Okay, we will finish with that. Okay, so I will go directly because I prefer to show you the platform in action. Okay, we have seen that for edge node, in every edge node, we have these two tabs here. We have the application and model tab. We have been working in to deploy application models, etc. But we have also this node information area. We have not spoken about that. We have not spoken about that. That is all the information about the edge node. Okay, so we can see the telemetry. We can see now we have 22 running processes here. Okay, because we have a lot of application running. So we can see the detail, for example, of how many resources are consuming every one of the process we have. Okay, we can see the RAM consumption, the CPU, or we can see also the number of files that every process has open, and also the general values of the equipment. Okay, all this information is also here in the analytic card. So for example, we can check, I want to show the last, yes, I don't know, the last hour, but instead of showing the RAM consumption, I want to show, I don't know, well, it is okay, the RAM, but I want to see the general consumption, but also this Triton server and this file browser, okay, these two processes. So I can do that. So I will see the information of the three processes separately, okay? And I can now download this information if I want to in CSV or image or whatever, okay? I can see the general information, the equipment. We can see, for example, some configuration, okay, global config or global secret are parameters that I can create on my edge node, and these parameters are available as configuration for the application, okay? So for example, in the secret, I normally save some, credential, certificate, anything I need to add. For example, imagine I want to use a certificate for an MQTT broker access or something like that. I can create it here, something like that. And then I can add a value here, or in case the certificate is a file, I can upload it from my system, okay, this way. So I can create this kind of information, and this information is available for the application, okay. This is the same concept, but in this case, what I am using is JSON. So I can declare variables and values using this JSON, and this also, all these parameters are available for the application for configuration purposes, okay. We have the detail of all the volume that have been created in the edge node. For those that do not know what a volume is, a volume is like folders that Docker create to store all the information for all the application locally in the edge node. So for example, I can see here, I have the folder influx that is using the influx database, or certificate for influx or data, etc. We can see how many space are they using. I can create new volume manually. I can delete all of them if I need that. So I can see all the information that is being managed by the application here. I can see also the network card that what we saw before to configure everything related to communication of my edge node remotely. And finally, I have some a way of including Docker credential here. What is the Docker credential? Okay. Normally, when we are downloading application from our marketplace, the registry, we are doing something. We send the Docker compose to the edge node, and the edge node has to download an image from a repository. Okay, the repository we use for marketplace, the credentials are already on the edge node, so there is not a problem. The edge node goes to the repository and it's able to download the image. In case you're using a public repository, okay, it is also possible to do because it's public. You can go there and download the information. But what if you have the application that you want to deploy? Is it in your own private repository? Okay, that is why we have this credential here. You have to indicate the node how to access to this repository, to this private repository. So you have to include the URL of the repository, the user, and the password. So this way you can create a new credential, and this node will be able to access the repository and get the information from there, even when it is private. Okay. Finally, more option we have here. We have the possibility of pruning all the information about Docker, okay? Pruning is deleting everything that is not necessary to be used anymore to save space, okay? Docker has a very really powerful cache that avoids you to repeat tasks when they are done. For example, if I download an image, I save it on the cache. So the next time I'm going to use that image, I don't have to download it again. This is a good thing and save time. The drawback is that it use a lot of space in the edge node, okay? So if you want to save space, you can prune the images, you can prune the container, you can prune the network, or you can prune everything here, okay? So everything that is not under use, it will be deleted from the edge node, okay? And in case you are having some problem with the Docker, that is something that may happen when you're debugging, developing application, you can always restart the Docker daemon remotely. It is very useful functionality also, okay? Obviously, we can update the firmware of my edge node remotely, every time you have a problem. Or sorry, every time you have an update, you will see a notification that is indicating you have the possibility to upload the OS of the Node Manager. The Node Manager is an application that is the application that connects to the API and speaks to the OS to apply every command that it receives and so on and so forth. Okay, so this way you can update your equipment, but also you can reinstall it. Okay, if, for example, you want to reinstall your actual OS, you can do that this way. You send this command and your edge node will be reinstalled again. Okay. And finally, you can also reboot your system, shutting it down, deactivate, manage the life cycle of the edge node remote. Okay. Last couple of things. Let's speak a little bit about the batch command. We have been speaking about one single edge node, okay, but obviously all the commands that are available for a single edge node are also available for a group of edge nodes. So we can select all of our edge nodes in this organization, for example, and we can manage them in a group, as a group, okay? So I can, for example, reboot all of them in parallel, or I can change the Ethernet configuration, or I can install any Docker application or any marketplace application, or send any AI model, or update the firmware, for example, if I want to check that when I do that, I will see the command here, the detail of what I'm going to do, and even when I have some nodes that are offline. In this case, I have a couple of edge nodes that are not connected to the system, probably because they are powered down or they have any communication problem, okay? And it's not a problem. This is not a problem for Barbara. We are an edge platform we use to handle this kind of situation. Whenever both devices get online again, they will receive the command that they will apply it. So you don't have to worry about that, okay? So you don't have to say, oh no, they are offline, I have to wait until they are online again to send the command. It is done automatically for you, okay? So this kind of command is really, really powerful. Obviously, they are also dangerous if they are not used knowing what you do. That is why these commands are only available for supervisor user or administrator user. We have different profile for user. So depending on the user you are, you can do one thing or another. Okay, so I have this button here, save and launch, because I am administrator in this demo account, but you can see that will be able in your organization to, when you declare a new user, you can select the role you want to apply to that user to, have a different role for different permission, etc. Okay, so this is the way of managing big group of nodes, as you know, which is one of the most powerful functionality we have in Barbara. Okay, and let's finish this last 5 minutes. This last 5 minutes speaking a little bit about high availability. Okay, let's try to explain that. What is high availability? Imagine I have a customer that demands me, okay, I want to have an a Grafana or a node-RED, okay? I want to deploy a node-RED with some task, some flow, creating some tags or whatever, and I want the services to be running 100% of the time, no matter what happened, okay? So if that is a requirement, I cannot deploy just a single node-RED application on a single edge node, because if my edge node break or have any power supply problem, or something happened to this edge node, the service will be interrupted, obviously. Okay, I cannot control that. So how can we avoid this kind of situation? Okay, how can I guarantee my user that the services will be running 100% of the time? Creating clusters. Okay, what is a cluster? A cluster is a group of edge nodes that work as a group. Okay, they are synchronized and they share application and they share the data among them. Okay, that is what we have here in this option, cluster. Okay, so this way we can add new cluster indicating a name, for example, I don't know, cluster name 1, and then I can enable volume for cluster. That is a way of having like a shared folder where the application will store the data, and all this data will be available for all of the edge nodes in the cluster. I can also enable a virtual IP, okay, so this way I will use just a single IP to access the services, no matter where they are, if they are in node 1 or node 2. Okay, I don't have to worry about that. I just need to use this virtual IP as declared here. Okay, I have this cluster created already for this demonstration. Okay, so in this case, check, we have 3 edge nodes here: edge node 1, edge node 2, and edge node 3. Okay, we have, as you can see, a really similar interface than for a single edge node, with some more or less the same card. And we have also the applications and model card. Okay, check that. So let me show you that the edge node have different statuses. We can see this node is active, this node is active, but it is drained. So, okay, so I will just activate this node again. So what is activating a node? Activating a node, here it is active again, is just making it available for receiving application. Okay, so what we are going to do right now is we are going to deploy a node-RED application on top of this cluster. Okay, so let's do that. I will just send the node-RED, okay, with default values. And here I have more steps. I have to indicate if I want to deploy how many instances of the node-RED I want to deploy in this cluster, because I can do something like this, just installing one. Okay, so I will install one node-RED in one of the edge nodes. Okay, or I can say I want to install 2 or 4, I don't know, as many instances as I want. Okay, or I can say I want to have a global deployment mode. What this does is deploying one instance in every edge node. So in this case, just for demo purposes, I will just indicate I want to use one single edge node-RED in the whole cluster. Okay, so I will send it, and I will see that in some second, I will see exactly the same that for a single edge node. I will see they have a node-RED with the same card, with some different here, okay, because I can see that this node-RED is in the cluster node 3, okay, where it's located and it's starting. I can see also the log here, okay, so more or less it's the same. If I go back to the cluster information, I can see that node 1 has no application and model, node 2 has no application and model, and node 3 has one application, which is obviously this node REST. So now, imagine I want to do something like updating the version of my node 3, this one, okay? In this case, when I apply an update, the node has to restart, okay? And during the time it is restarting, the service will go down. So I have to be careful about that. What can I do? I can say, okay, I'm going to drain this node because I can pause it. When I pause a node, it doesn't get more tasks, it doesn't get more application, it just gets the application it has. Or if I drain my node, what it does is moving the application to any other node in the cluster, okay, and keep quiet to do something like a reboot, like updating or something like that. But it is a way of showing you how the application will move to the other node, okay? So just to show you how can we access here, we see that we have this virtual IP, okay? So if now I can use this IP to access these services, no matter where it is. Check it is in the cluster node 3, in this node. But I'm not going to use the IP of this node. I am going to use this one. So I just open a new tab on the port 1880, and I will be accessing this way to the node rest, as you can see, okay? So now check that if, for example, I drain my node, okay, it will transfer the application to the other node, okay? And we will see in some second that it has been drained, and this application will disappear from here, okay? And it will move to this one or this one. I don't know. Let's check it. Uh, Here we are. It is now in cluster node number 2. Okay. So this node has not the application, it's here. But if I refresh my application, it is still here. So the application is still on and the data is still available. So you have the application running 100% of the time, no matter what happened to your edge node. So this is a way of having redundancy to guarantee that your data and your application will be running 100% of the time. And well, with that little demonstration of how can we manage high availability, I think we have covered all the all the thing we wanted to show in this tactile session. So I don't know. Do we have any more questions, Emilia?
I believe at the moment there are not any more questions, but I just want to
Okay.
take this opportunity to thank you, Enrique, so much, and thank everyone here for their time and their questions. It's been quite an intense session, but it's also been very fruitful. Please, if you have any questions, do not hesitate to contact us via email, or you can also do it through LinkedIn if it's easier. We're very happy to help and solve any of your questions. And please remember to take a look into the resources that we have shared today. Before we let you go, I just wanted to mention, please, if you don't mind, take a minute to answer the survey. We would love if we could get your input and feedback to shape our other webinars and sessions. So that would be great. And with that said, thank you so much for your time today. We truly appreciate it. And thank you, Kike, and everyone. I don't know, Kike, if you want to say something before we go.
No, just nice to be with you today. Well, the academy is open. You can check it. You can check the possibility. And in case you're interested in having some demo license or some trial license, please let us know. Okay, communicate with us, and we will be happy to provide one for you. And thank you.
Exactly. Well, we'll let you go now, and thank you so much.
Bye bye.
Have a great day. Bye bye.